All right, so we have one more part to these notes, section 3. Now it's called using multiplication. If you look at number 11, you're going to see right away that we have kind of a problem. And the problem is that the x's, the coefficients, are not opposites. 4 and -1 are not opposite numbers. And we have the same problem with the y's. They're not opposites. So if I try to add right now, okay, you don't write this down because this is going to be wrong. If I add, the problem is I get 3x. That becomes -1y equals 14. I can't solve that. I can't get x equals a number or y equals a number because I did not eliminate either variable. Okay, so I can't use this yet. I'm not going to use this technique. But to be able to eliminate, remember that what we need is we have to get opposites. So I'm going to do that. Now in this case, what I'm going to ask myself is when I look at x and when I look at y, is there a way that I can make them the same value, the same coefficient, opposite coefficients? So in other words, this is 4x. How could I make that -4x? Well, the answer is I could multiply by 4. Because 4 times -1 is -4x. I am allowed to do this as long as I multiply everything, every part of this equation by the same value. Multiplying by the value, left side, right side, does not change the equality. So we have equation 1, equation 2. I am going to keep equation 1 the way it is. 4x minus 3y equals 12. But equation 2 is I am going to multiply each piece by 4. So I'm distributing, that would be -4x. This would become positive 8y. And then 2 times 4 equals 8. Now look at our system of equations. Look at the x's. Notice that these are opposites. So now I can add my equations together. So I'm going to add the left side. That's 0x, gone, eliminated. -3y plus 8y is 5y. 12 plus 8 is 20. Now we can solve for y. Divide by 5, y equals 4. Now what do we need? We still need to find the x value. I am going to take equation 1. I really don't like having the negative coefficient for x. So I'm going to take equation 1. 4x minus 3y equals 12. But the y value is 4. So multiply, that's -12. We'll add the constant. Move that to the right side. 4x equals 24. Undo multiplication by dividing. X is 6. And so the answer is 6, 4. Okay, so what we needed to do for elimination was we had to first get the equation in a form that allows us to eliminate when we add the two equations. So we have to get opposites. Now you might be thinking, well, what if I had wanted to eliminate the y values? Okay, so just to show you, I'm not going to go through all of it. I'm going to rewrite. This was the original system here. If we had wanted to eliminate the y's, you have -3 and you have +2. What we need is a common multiple, and both of those go into 6. So what I would do here is I would take the top equation and multiply by 2. That would give me 8x minus 6y equals 24. So I would make this a -6y. To make this a +6y, I would have to multiply here by 3. And that would become -3x plus 6y equals 6. Now these are opposites. So now I would add, we would get 5x, 0y equals 30. And if you divide by 5, you get x is equal to 6. Okay, now why didn't I do that? Well, because I would have had to change both equations. I would have had to multiply both equations. So if I can get away with just doing this one time, I'm going to save myself work. So when you look at these, you need to kind of plan ahead. You need to ask yourself, what can I do and what might be the easiest way to do it? All right, so let's look at number 12. Equation 1, equation 2. 2x, 3x. This is 1y, negative 2y. Now I like the y's because if I have a 1 here, this is negative 2y. If I could change this to positive 2y, then I can eliminate the y's. So what can I multiply by to make this positive 2? Well, 1 times 2 is 2. Now remember, you have to multiply every part of the equation by this number. So equation 1 now becomes 4x plus 2y, and I have to do the right side, that's 10. 3x minus 2y equals 4. Now that we have opposite coefficients, we add the equations together. So the left side is 7x, this is 0. By the way, if this doesn't add up to 0, we've made a mistake. Okay, so that's a way that you check yourself as you're going. 10 plus 4 is 14. We can divide that, we can solve it. X equals 2. All right, now we need to find the y. I'm going to take equation 1, which was 2x plus y equals 5. Notice that I go back to the original equation in this case. Okay, I'm not going to go to this. This is more complicated. So I'm going to go to the equation that I started with before I did any kind of multiplication. So what is x? X is 2. 2 times 2 is 4. Plus y is 5. Well, minus 4. Y is equal to 1. And we have a solution. We have 2 comma 1. Whoops. Now the last thing, again, I should check. So if I take here 2 times 2, that's 4, plus 1, does it give me 5? Check. 3 times 2, 6, minus 2 times 1, 6 minus 2 is at 4, check. And there we go. All right, last one here, number 13. Equation 1, equation 2. So we have x's and y's. 3x, 5x, we would have to make those 15 and negative 15. But negative 2y and positive 4y, oh, we can do that. If we can make this negative 4y, we could eliminate. So I like the fact that it's negative and positive. So to make that negative 4, we are going to multiply by 2. We don't need to multiply by negative 2 because we already have the negative there. So equation 1, 6x minus 4y equals 38. And then this is 5x plus 4y. I'm just copying that down. I'm just rewriting it. I like to keep my equations together. That's why I rewrite. You might think, well, why do I have to copy that? I like to keep this together. It's easier to see. Now that we have opposites, we're going to add. I'm going to put that plus sign there. 6x plus 5x is 11x. The y's eliminate. 38 plus 17 is 55. We can solve that. 55 divided by 11 is 5. Now to find the y, I'm going to take the second equation this time. 5x plus 4y is 17. The x is 5, so 25 plus 4y is 17. Let's subtract 25, left side, right side. That's negative 8. Divide by 4, and we get y equals negative 2. One thing you need to be aware of, keep track of which variable is which, x and y. Be very clear about that, because you don't want to switch this at the end and then realize you made a mistake. And that is the end of part 3 of the notes.